You know, a lot of people think programming is some kind of dark art, reserved only for math geniuses. But what if I told you it's actually simpler? Like making a sandwich simple. Seriously, in this explainer, we're going to pull back the curtain on programming and show you that it's all about one core skill, learning to think logically.
So, here's the plan. We're going to start by looking at algorithms as just simple recipes. Then we'll see how to visualize that logic using something called flowcharts. And you'll see how that same idea can go from making a sandwich to, believe it or not, saving bees. After that, we'll get into the real nuts and bolts, the 3 basic building blocks of all software. We'll even cover how to plan for when things go wrong, and then we'll tie it all together so you can start thinking like a programmer.
All right, first things first. Let's tackle that big, scary word right away, algorithm. It sounds super technical, right? But I promise you it's not. In fact, you use algorithms all the time without even realizing it. They're way simpler than they seem.
Okay, to really get this, let's try a little thought experiment. How would you tell a computer, which is basically a super powerful but incredibly dumb robot, how to make a sandwich? You can't just say, hey, make me a sandwich. It has no common sense, no context, it would just freeze. And that right there is the whole point. You need simple, crystal clear instructions. That's the heart of what an algorithm is. And here it is, the official definition. But don't get hung up on the fancy words. The most important parts here are simple and clear. See, computers are ridiculously fast, but they're not smart. They can't guess what you mean. They need a recipe, a set of instructions with zero room for interpretation to get anything done. I mean, look at this. Step 1, 2, 3, 4. It's so simple, right? There's absolutely no way to misunderstand this. A computer could follow these instructions perfectly because every single step is spelled out. And this idea, this super predictable step-by-step process, that's it. That is the bedrock of all programming. Okay, so a list of steps is great, but what happens when things get a little more complicated than just making a simple sandwich? Well, it really helps to see the logic, and that's where flowcharts come into play. They're basically a way to turn our written recipe into a picture, a visual map of what needs to happen. And you don't need to be an artist to understand these. It's just a few basic shapes. Ovals, that's your start and finish. Rectangles, those are the action steps. You know, do this. But the diamond is where the magic happens. That's a decision point. It's where our simple recipe starts to think by asking a question that can change everything.
So, check this out. On the left, that's our original sandwich plan. Just a straight line, start to finish. But look at the right. We've added one little diamond, and suddenly our algorithm is smarter. It asks a question. Are you a vegetarian? And depending on that yes or no, it takes a different path. You either get cheese or you get ham. Just like that, we've given our program the ability to make a choice.
All right, I know what you're thinking. Sandwiches? Big deal. But here's why this really, really matters. Because the exact same simple step-by-step thinking that we use to make a sandwich, you can use that to solve massive, complicated, even life-and-death problems. Seriously. So let's look at a real-world problem. Beekeepers are in a tough spot. They're dealing with this invasive species, the Asian hornet, and it's devastating. These hornets attack and wipe out entire bee colonies. And that's not just bad for bees, it's bad for our whole ecosystem. So what did engineers do? They built a system based on an algorithm. It's pretty genius. It has a microphone that just listens for buzzing. Then it analyzes the sound, the exact frequency of the wing beats, and uses that data to make a decision. Is this a friendly neighborhood bee, or is it a dangerous hornet? And if it detects a hornet, boom, it sends an alert. And this is the mind-blowing part. That whole complex system for saving the bees, you could draw it out using the exact same kind of flowchart we used for the sandwich. It's the same fundamental logic, actions and decisions. It's just been scaled up from a snack to saving a species. That's the power of this way of thinking. Okay, so if the flowchart is the blueprint, what do we actually use to build the house? Let's talk about the tools programmers use to turn these cool diagrams into actual working code. And here's the kicker. Everything you see, every piece of software, is built from just 3 basic ideas. I want you to really let that sink in. Every single app, every website, every video game, it all comes down to these 3 things. You've got sequence, which is just doing things in order. You've got condition, which is making a choice. That's our ham or cheese moment. And you have a loop, which is just repeating something over and over, like your phone constantly checking for new emails. So let's talk about those conditions, those choices. For a program to make a choice, it first has to ask a question. And these questions are always super simple comparisons, like, is this number the same as that number? Or is this thing bigger than that thing?
And the answer is always, always just a simple true or false.
And these symbols you see here? These are the tools for asking those questions. The double equal sign is just asking, are these two things exactly the same? The one with the exclamation point is asking, are they different? And then you have the good old less than and greater than signs. Every single decision your computer makes boils down to one of these.
Okay, on to loops, doing things again and again. There are two main flavors, and the difference is pretty easy to grasp. A for loop is like saying, okay, do this exactly 10 times. No more, no less. But a while loop is more like saying, just keep doing this until the coffee pot is full. You don't know how long it'll take, you just know the condition for stopping. So we've got our plan, our blueprint, our building blocks, everything seems great. But what happens when the real world gets messy? What happens when things go wrong? Because trust me, they always do. A huge part of being a good programmer is planning for the unexpected.
Just imagine this. Your program asks someone for their age, and instead of typing 25, they type cat. What's the computer supposed to do with that? It can't turn the word cat into a number. It's impossible. So with no backup plan, the whole program just gives up. It crashes. Game over.
This is where a little thing called a try-except block comes in, and it's basically a safety net for your code. It's brilliant. You tell the computer, look, I want you to try this piece of code, but it might break. If it works, awesome. But if it breaks, instead of crashing the whole show, you tell it to jump to the except part, which is your plan B.
And look at the difference this makes. On the left, no safety net. The code hits that impossible request and the whole thing just dies. But on the right, with the try/except block, it catches the error, maybe prints a friendly, hey, that's not a number, message, and then just keeps on going. This is what makes software feel stable and not fragile. Okay, so we've covered a lot of ground here, right? We went from making sandwiches to saving bees, from drawing pictures to writing code. So let's bring it all home. What does it actually mean to think in algorithms?
Here's what I want you to walk away with. Programming isn't magic. It's not some secret code only geniuses can understand. It's just a way of thinking. It's about looking at a big, messy problem and having the confidence to say, okay, how can I break this down into a simple recipe? It's about using those 3 building blocks to create something new and being smart enough to plan for errors. It's logic. It's creativity. It's problem solving.
So I'll leave you with this question to chew on. Think about your day so far. The route your GPS chose for you, the songs your music app suggested, the posts you saw on social media, all of that was decided by algorithms. Our world is literally running on these invisible sets of instructions. So the question is, what hidden algorithms are running your life right now?